Welcome back. Today we're going to do finding dy by, oh, what happened there? We're going to have derivatives of x equals a function of y. Okay, so up until now we've been doing y equals f of x. We've been taking the derivative of those, dy by dx equals blah blah blah. We've taken the derivative with respect to x. In other words, we've got y, some function of x, and the derivative, we look at the functions of x. I don't think I've said that, it doesn't matter. What we're doing now is the other way around when we've got x as some function of y. In other words, something like x equals sine y, or x equals y squared plus e to the power y, things like that. Can you see how this is very different to y equals x squared plus e to the x? So this is what we've done up until now. This is what we're going to look at now. And it's quite important when we come to like inverse functions and things like that to be able to go both ways. And the key ingredient here is that if you're trying to find dy by dx, a good, nice way to do it, instead of, if you think about it, if you've got a question like this, to be able to find dy by dx, you need to rearrange this so that you get y equals something. But can you see how that it's actually not possible in this situation to get y by itself? It's very, very tricky. And so another way to do it, instead of rearranging it, transposing it for y and then taking a derivative, it's actually more convenient in most cases to go, that is equal to 1 over dx by dy. In other words, take the derivative of x with respect to y, so it's backwards of what we've been doing, so just take the derivative of this with respect to y, and then to flip it upside down, 1 over that. So this is the key ingredient here. And let's just jump straight into some examples of that. Okay, let's have a look at something. Example. Yeah. So let's have a look at it. If x is equal to 2y plus 7 cubed, find dy by dx. Okay, so let's have a look at this. Again, trying to rearrange this for y is a pain in the butt, and so what we want to do is do it the simpler way, which is to find what is dx by dy. So what we want to do is take the derivative of this with respect to y, which is the same thing as with if it's with respect to x, but just with a different variable. So do the same thing. Here we have the chain rule. So what does the chain rule say? We differentiate the outside function. So the 3 comes down the front, we leave everything on the inside as it is, that 3 becomes a 2, and then we multiply it by the derivative of what's on the inside. The derivative of what's on the inside is just 2. So that's equal to 6 bracket 2y plus 7 squared. Good, that's dy by dx, and so therefore dy by dx is equal to 1 over dx by dy, and so what we just do is we just flip that upside down, so it's just 1 over 6 2y plus 7 squared, and there's your answer. That's what we're doing here, and you've ended up with dy by dx in terms of y, not x here. Okay, so that's the factor that makes this simpler, because if you had to find out what y was equal to, it's what we're talking about. If you're trying to solve for y in here, it's very, very messy, and so that's why this is a cleaner way to do it, because it's in terms of y. So there we go. There's an example. Let's do a more tricky example. I'm just going to do this quickly because I want to get the thing. Actually, I just might move straight on to that. Find the gradient. Find the gradient of x equals e to the 3y when y is equal to 2. Okay, so let's do that. So find the gradient. Now remember, the gradient, you need to always remember that gradient is dy by dx. Okay, so that's what we need to find, dy by dx. Dy by dx, but we've only got this x as a function of y. We could rearrange this, and that's not actually too bad, but what the easier way to do it is just do this, especially because y is equal to 2. We want it in terms of y anyway, so much easier. So dx by dy, the derivative of this is the chain rule again, okay? So the chain rule says, take the derivative of the outside function, which is just e to the 3y. The 3y stays the same because it's the chain rule. You just leave the inside function the same, and then you multiply that by the derivative of the inside. The derivative with respect to y of 3y is just 3. So that answer is 3e 3y. Okay, there's dx by dy. Therefore, dy by dx is just that upside down. So that's 1 over 3e 3y. That's our dy by dx. Therefore, what we want is the gradient. Therefore, the gradient, I'll just write it. I'll write it as gradient when y is equal to 2 is equal to 1 over 3e. 3 times 2 is 6. And that's your answer. So, unless it asks for an approximate, that's your exact answer there. Okay? So, there we go. That's what we're doing there. What about if it asks for something when x is equal to something? Let's just have a look at that one. Find the gradient. I'm just going to write dy by dx, save myself a bit of time. Of a curve, let's just x equals cos 2y when x is equal to 0. Okay, so let's have a look at that. Again, find dx by dy because we've got a function in the opposite way there. Sorry about that, I don't know what happened there. I accidentally hit the little buttons on my pen. Right, find the derivative of this. Now this is the chain rule again. You've got the function 2y inside of cos y. Now, so differentiate the outside. What's the differential of cos? It's negative sine. We write the inside, we leave that as it is, 2y, and then we multiply this whole thing by the derivative of what's on the inside, 2. So that's just negative 2 sine 2y. And get good at those, get really, really fast at that. Okay. Therefore, dy by dx is just that upside down, so it's 1 over negative 2 sine 2y. Press that button again, 2y, like that. Perfect. Now, what we want to do is we want dy by dx when x is equal to 0. But this tells us it's only in terms of y. So what we want to know, what y is equal to when x is equal to 0. So therefore, when x is equal to 0, let's substitute it back into our relation here. Okay, so when x is equal to 0, we have 0 equals cos 2y. Therefore, therefore 2y is equal to cos negative 1 of 0. Where is cos equal to 0? Cos is equal to 0 up here and down here. Okay, and so therefore y is equal to, 2y is equal to, we'll have negative pi on 2 or pi on 2. So we've got two values of y here. Now, so we're going to get two values of y, and that will be, if you think about what the graph of this looks like, it will actually look something like, sort of like this, okay, going like that. And so we're going to get two different values, and so what we want to know is that we're going to get two different derivatives, so we have to check the 2 points. Okay, so therefore, when y equals negative pi on 2, the derivative, the gradient, will be equal to 1 over negative 2 sine 2 times y. That's negative pi, which is equal to what's sine of negative pi? So negative pi is there, the sine is equal to 0, and so we get an infinite or undefined gradient there. Okay, and when y is equal to pi on 2, y is equal to pi on 2, that was our other one, was it? Yep, pi on 2. The derivative is equal to 1 over negative 2 sine of pi. Again, sine of pi, that's also equal to infinity, which is undefined. Okay, and so what that tells us is what's the gradient of the curves at when x is equal to 0? They both lead us to say that undefined gradient, which means that the line is going straight up. Okay, so up dead straight, and if you look at this, when x is equal to 0, you're getting the points. Oh, that would be that there. Yep, that's right. So dead straight up. And there you go. Thank you, and I'll see you next video.